Hello everyone, I am Sandeep. I am here to discuss about propositional logic. Propositional logic is a branch of mathematics that studies propositions as a whole and connected by a logical connectives. In this article, we have covered propositional logic and related topics in detail, and this table of contents is given below, which consists of what is logic, propositional logic, truth table, which consists of negation, conjunction, disjunction, exclusive or implications, and biconditional or double implications. Now let us understand about what is logic. Logic is the basis of all mathematical reasoning and all automated reasoning. The rules of the logic specify the meaning of mathematical statements. These rules help us understand and reason with statements such as there exists x such that x is not equal to a square plus b square where x, comma a, comma b belongs to integers, which in simple English means there exists an integer that is not the sum of two squares. Now let us understand about the importance of mathematical logic. The rules of the logic give precise meaning to mathematical statements. These rules are used to distinguish between valid and invalid mathematical arguments. Apart from its importance in understanding mathematical reasoning, logic has numerous applications in computer science, varying from the design of digital circuits to construction of computer programs and verification of correctness of the. Now let us understand the types of the proposition. In propositional logic, propositions are the statements that can be evaluated as true or false if they are building blocks. They are the building blocks of more complex logical statements. Here is a breakdown of the two main types of propositions. One is atomic proposition and another one is compound propositions. Let us understand about propositional logic. A propositional logic is the basic building block of logic. It is defined as a declarative sentence that is either true or false, but not both. The truth value of a proposition is true if it is true statement and false if it is false statement. For example, the sun rises in the east and sets in the west. 1 plus 1 equals to B is a vowel. All of these statements are proposition where the first two are valid and a third one is invalid. Some sentences that do not have a truth value or may have more than one truth value are not proposition. For example, what time is it? Go out and play. X plus 1 equals 2. The above sentences are not proposition as the first two do not have the truth value and the third one may be correct or false. To represent proposition, propositional variables are used. By convention, these variables are represented by small alphabets such as P, Q, R, S. The area of logic which deals with a proposition is called propositional calculus or propositional logic. It is also includes producing new propositions using existing ones. Proposition constructed using one or more propositions are called compound propositions. The propositions are combined together using a logical connectives or logical operators. It is shown below table. Let us understand about the truth table. Since we need to know the truth value of the propositions in all possible scenarios, we consider all the possible combinations of the propositions which are joined together by the logical connectives to form the given compound proposition. These compilation of all the possible scenarios in a tabular format is called the truth table. Most common logical connectives are negation. If P is a proposition, then the negation of P is denoted by negation of P, which when translated to simple English means is not the case that P, or simply not P. The truth value of not P is the opposite of the truth value of P. The truth table of not P is given below. True will become false, false will become true. Now let us understand about conjunction. For any two proposition P and Q, their conjunction is denoted by P and Q, which means P and Q. The conjunction P and Q is true when both P and Q are true, otherwise false. The true table is given below. Let us understand about disjunction. For any two proposition P and Q, their disjunction is denoted by P or Q. With the disjunction P or Q is true when either P or Q is true, otherwise false. The true table is given below. Let us understand about exclusive OR. For any two propositions P and Q, their exclusive OR is denoted by P exclusive OR Q, which means either P or Q but not both. The exclusive OR uh, is true when either P or Q is true and false when both are true or false. The truth table of P exclusive OR is Q is given below. Next one is implication. For any two propositions P and Q, the statements if P then Q is called the implication and it is denoted by P implies Q. In the implication P implies Q, Q is called the anti hypothesis or antecedent or premise, and Q is called the conclusion or consequence. The implication is P implies Q is also called a conditional statement. This implication is false when P is true and Q is false. Otherwise, it is true. The truth table is given below. You might wonder that why P implies Q is true when P is true. This is because the implication guarantees that when P and Q are true, then the implication is true. But the implication does not guarantee anything when the premise P is false. There is no way of knowing whether or not the implication is false since P did not happen. This situation is similar to the innocent until proven guilty stance, which means that the implication P implies Q is considered true until proven false. Since we cannot call implication P implies Q false when P is false, the last one is biconditional or double implications. If any two proposition P and Q, the statement is P if and only if Q is called biconditional and it is denoted by P if and only if Q. The statement P if and only if Q is also called by implications and has the same true values as P implies Q and Q implies P. The implication is true when P and Q have same truth values and is false otherwise. The truth table is given below. Thank you.